we're going to be dealing with, the absolute value is less than something. On that last one, we showed that the greater than symbols will always give you an or statement. If it's a less than symbol, it's always going to give you an and statement here. But here's why. We want the distance from 0 to be less than 5. Well, for the distance to be less than 5, it's got to be in this region over here. All right, before 5, I guess. If it was over here, that would be a distance greater than 5. But it also can work for the negative side. Values that are between -5 and 0 also have a distance that is less than 5 from 0. So your inequalities would be anything that is less than 5 and anything that is greater than -5. All right, so we're gonna include all values that are greater than -5 and less than 5. All right, so that's why it's going to look like an and statement, where the dots are connected, basically. Right. First example here. All right, so we're solving the absolute value of x minus 8 is less than 5. All right. So the first version is just going to be the regular version. So x minus 8 is less than 5. And the second version is going to be x minus 8, and we're going to flip the sign and make that a -5 instead. So flip the sign and change the sign. All right. Solve each of these. We're just going to add 8 to both sides. This is going to give us x is less than 13. And on this side, if we add 8 to both sides, we're going to get x is greater than, -5 plus 8. That's +3. All right, and then keep in mind it's an and statement here. So we want numbers that are greater than 3, so open dot at 3, greater than 3, and they have to be less than 13. So this is going to be an and, so we'll connect the dots. It's less than 13, and it's also greater than 3. The interval notation for this is actually kind of nice. It's easy. So all numbers between 3 and 13 is just 3, 13. And because these are both open dots, it'll be parentheses on both sides. All right. Second example here. All right, so we'll break our problem into two cases. We've got the normal version where -5x minus 4 is less than or equal to 11. And then we've got the negative and flip version. So -5x minus 4, we'll flip the sign and change it to -11 instead. All right, and then because it's a less than symbol here, we're going to have an and statement. For both of these, actually, we're going to be adding 4 to both sides. So we get -5x is less than or equal to 15. Divide both sides by -5. Because we divided by a negative, we need to flip our sign. All right. And then on this side, add 4 to both sides. We'll get -5x is greater than or equal to -11 plus 4. That's going to be -7. All right, and then divide by -5. Okay, the -5s can cancel with each other. We'll flip the sign, and a negative and a negative is going to make a positive 7/5. Or if you want to make it a decimal, it'd be 1.4. All right. So on our number line, our graph here, there's 0. That can be our -3 marker. It's a closed dot at -3. And then at 1.4, we'll have a closed dot at 1.4. All right, so we want it to be greater than -3, so going this way. And we want it to be less than 1.4, so going this way. So we'll connect the two. All right. And then as far as our notation, we'll have -3, 1.4. And it's brackets on both because the endpoints were included. All right, they were closed dots.